Okay, so we will wait for 3 more minutes and then we'll get started. Okay. Okay. Uh, okay, so maybe we'll get started. It's 3-5. Let me share my screen. Okay, so the recording is going on. Anyway, so okay, so hello, namaste and welcome everyone. Welcome to this tutorial session, problem solving session. So this is sixth session, right? And and in this problem solving session, we will mostly be discussing or solving problems related to bivariate random variables, random variables, and bivariate normal distribution, right? So these will be the topics on which we will be solving a lot of problems. Uh, so maybe maybe I'll start by just from bivariate normal distribution, right? So before we start with normal distribution and its problems related to it, let's look at the joint density. What is the bivariate normal distribution actually, right? So we say that uh, two random variables x comma y are jointly jointly Gaussian or normal if their PDF or density function has a particular form, right? So what is that form? So fxy of x comma y, if this is equal to this some expression, what is that expression? That expression is 1 by 2 pi sigma x sigma y square root of 1 minus rho square exponential of minus 1 by 2 times 1 minus rho square times x minus mu x by sigma x whole square plus y minus mu y by sigma y whole square minus 2 rho x minus mu x by sigma x y minus mu y by sigma y. Okay, this much. So if two random variables have this joint density function, then we say that they are jointly Gaussian, or they are bivariate normal random variables, so to say, right? And as you can see, there are a lot of parameters in this expression. It's a complex looking expression, but it also has some pattern. Like, I mean, if you get like maybe if you get comfortable with it, you can see, right? It's almost like a plus b whole square. However, there's a row sitting here and stuff like that. You can make up your own way to, memorize this expression somehow. Uh, Nonetheless, what are these mu x, mu y, sigma y, and rho? So just for the sake of completion, right? Mu x is just expected value of x, right? Mu y is expected value of y. Uh, what is sigma x? Sigma x square is basically the variance of x. Sigma y square is variance of y. And what is rho? Rho is your correlation coefficient, which is equal to what? Expected value of xy minus expected value of x, expected value of y, divided by uh, variance of x times variance of y, square root of it, right? This is your rho, which is also called the correlation coefficient, right? Okay. So yeah, I mean, a lot of things here, but I mean, if you solve a lot of problems, you will get very familiar to this expression. It's quite it's just a matter of getting familiar with it. But yeah, depends on your uh, the way you practice and go about the subject. Anyways, so let's start with a very simple question. Starting with a very simple question, which just requires you to memorize this form of this joint Gaussian distribution, right? So let's start with our first question. Yeah, by the way, again, I mean, if you have any question, you can just unmute and speak up, or you can write in chat. However, I will not check the chat regularly because I also have to see the question. So I will see the chat after each question. So if you have a pressing question, you can just unmute, or if you don't have any pressing question, maybe you can write it on chat, whatever feels comfortable to you, right? So, the first question is goes as follows. There's a bivariate normal random variable, right? Uh, so x comma y, it's a bivariate normal random variable with some mu x, mu y, comma you have your uh, some variance, right? Uh, Okay, I mean, I hope you understand what this is. Sigma is basically a matrix. So when you talk about multiple random variables, you are actually talking about a vector valued random variable, right? And hence everything can be written in form of vectors and matrices. So sigma is nothing but this is sigma x square, I suppose. This is sigma y square. This is rho times sigma x square. This is rho times sigma y square, or something like that. I mean, I don't remember the exact form, but yeah, it's something like that. Yeah. Okay. So it's a jointly Gaussian random variable, right? X comma y, and it's given to you that its density is as follows: fxy is equal to this thing 1 by 2 pi sigma x sigma y times 1 minus, okay, I mean, okay, so this is not given to you directly, sorry. So the given thing in the question is it's 1 by 2.4 pi exponential of minus 1 over 0.72 times x minus 1 uh, x minus 1 by 2 whole square plus y minus 2 by 1 whole square plus minus 1.6 times x minus 1 by 2 times y minus 2 by 1. Alright, so this is given to us. The question that is asked is you have to calculate what is the expected value of x, expected value of y, and you have to find covariance of x comma y, right? You have to find these three quantities. It's given that x comma y is jointly Gaussian, and you know this is the distribution. How do you go about it? So if you know nothing about Gaussian random variables, you might be tempted to like evaluate this as, you know, integral x fx of x dx and so on. However, that's a very lengthy process. I mean, you will have to first find fx of x, I mean the marginals, by, you know, marginalizing y, and it will be a very difficult process. But since you know what uh, since you know what these random variables are, you can actually just compare this to the distribution of a standard nor like bivariate normal distribution, right? So I mean, you just need to compare this, uh, just need to compare this thing with this thing. That's all. So it's actually quite simple if you do that, right? So I mean, it becomes just a matter of matching things. I mean, if you see the thing that is subtracted from x, which is mu x, right? What is that thing here? It's 1. So you can say that, you know, your mu x is equal to 1, which is your expected value of x, right? Then the thing that is subtracted from y is mu y. So what is that? That is given to you to be 2. So expected value of y is given to you to be 2, right? Further, what else is given to you? It is also, you can also see that whatever is in the denominator, right? This is sigma x. What is the equivalent of sigma x in this expression? Sigma x is nothing but, you know, sigma x is given to you to be 2 here, right? It's equal to 2. Similarly, sigma y is this thing, which is given to you to be 1. So expected value of x and expected value of y were quite simple because you just saw them, you know, from the expression. What about covariance? So uh, so covariance of x comma y, this is equal to what? If you remember, if it's equal to expected value of xy minus expected value of x times expected value of y, right? Now you know what is expected value of x, you know what is expected value of y, but you don't know what is expected value of xy, right? So for that, what you can do is you can make use of the thing which is rho, which is your correlation coefficient, right? Because it contains your expected value of xy. So so how do you do that? You can see that whatever is there outside the bracket is actually 2 times 1 minus rho square, right? So this thing 0.72 must be equal to 2 times 1 minus rho square, right? Or you can also calculate it from here actually. 2.4 pi should be equal to this quantity, right? So maybe let's use that. So 2.4 pi with this thing should be equal to what? This thing, right? 2 pi sigma x sigma y 1 minus rho square root, right? 2 pi sigma x sigma y square root of 1 minus rho square. Now sigma x sigma y is known to you, which is 2 and 1. So this will become 4 pi square root of 1 minus rho square. Pi gets cancelled, right? And what else? Uh, 1 minus rho square raised to 1 by 2. This becomes 2.4 over 4, which is 0.6, right? This implies 1 minus rho square is what? 0.36, right? Square of 0.6. This implies rho square is equal to what? 0.6464, and hence rho is equal to square root of 0.64, which is what? 0.8, right? 8 square is 64, right? So 0.8. Now we can make use of this rho to calculate expected value of xy, right? So what is that? So 0.8 is equal to what? Expected value of xy minus expected value of x times expected value of y. What is it? Expected value of x is 1, expected value of y is 2. So expected value of x times expected value of y is 2, just 2, divided by sigma x sigma y, which is again 2 times 1, which is again 2. This implies, or yeah, I mean, you don't even need, because this thing itself is the numerator, right? This thing is the numerator. This thing, this is equal to covariance of x comma y. So you can just say that covariance of x comma y is equal to 0.8 times 2, which is what? 1.6. So you have obtained this thing. Expected value of x, expected value of y, you already obtained 1, 2, and that's it. I mean, pretty straight. Just matching. You know, like the simplest possible question that can come from bivariate normal distribution is, just matching terms. Let me know if there is any question, or I'll move to the next question, right? Okay, so let's look at some easy problems, right? Uh, let us look at some easier problems, which just involves two random variable, discrete random variables, right? Okay, so here is the second question. The question says that you have a fair coin which is tossed three times, right? So there's a fair coin tossed three times, right? Uh, so X is basically the number of heads in the tossings, right? Okay, and Y is equal to the absolute difference between the number of heads and number of tails. So this is number of heads minus number of tails, absolute value of that. Okay, so these are two random variables that is given to us. The question is, what is probability of x to be equal to 1 given that y is equal to 1? This is the question, right? So yeah, so how do you solve this? uh, Again, just mostly in case of discrete random variables, you just need to create one table to get to the answer. uh, Maybe I will just show you how to do it. Okay, so let's create a table of all possibilities. It's simple, it's nothing big, just simple things. So what can be the value of x? The value of x can be either the number of heads in when a coin is tossed three times can actually be 0, so every time it's tail, or it could be equal to 1, right? Or it could be equal to 2, or it could be equal to 3, right? Right. Now what are the possible values of y? Y can it cannot be 0, because when can y be 0? when the number of heads and number of tails are equal. However, if you are tossing the coin three times, the number of either the number of heads will be greater than tails, or the number of tails will be greater than number of heads. So it has to be at least one, right? Can it be equal to two? Well, it cannot be equal to two, right? Because then it means that the yeah, it cannot be equal to two, because I mean, just think about it. For the difference to be equal to two, one of them has to be equal to 3, right? Either it can be 3 minus 1, which is equal to 2, or it can be 2 minus 0. But this case is not allowed because you have to toss the coin 3 times. If also this case is not possible, because if this is the case, then you are tossing the coin 4 times. That is also not which is not the case, right? So just convince yourself that y cannot be equal to 2. It can be equal to 1, or the other possibility is that y is equal to 3, when all the every time you get either head or tail, then the difference is equal to 3, right? Because it will be 3 minus 0, or it can be 0 minus 3, something like that. Only then it can be equal to this thing 3. Okay, now let us write the joint distribution of this thing, right? What is the probability that x is equal to 0 and y is equal to 1? Is this case possible that the number of heads is equal to 0, so this thing is equal to 0, however this thing is equal to 1, so it means that tails has to be equal to 1, but this is not possible because you have tossed the coin three times, right? So yeah, this is not possible, right? Because if this is 1, then it has to be equal to 2, which is contradiction. So this is not possible, so probability of this happening is 0. Is it possible that y is equal to 3 and x is equal to 0? So the difference, well, erase this, maybe. So h minus t mod of it is equal to what? 3, and h is equal to 0. Is this possible? This will imply that t is equal to 3. This is possible, right? Because it is possible that you toss the coin three times, and every time you get tails, then you can arrive at this possibility that x is equal to 0 and y is equal to 3. So it's not, the probability of it is not 0. It's a non-zero probability event. So what is the probability of getting three tails? So it's a fair coin. So 1 by 2 times 1 by 2 times 1 by 2, this will be equal to 1 by 8, right? Simple. Okay. What is the probability that what in which case h minus t could be equal to 1? I am talking about this scenario now. And h is equal to what? H is equal to 1. Is this possible? Well, yeah, it is possible. If h is equal to 1 and this modulus opens up as positive, then 1 minus t is equal to 1. This implies t is equal to 0. That is not possible, right? So this case is not possible. So what if the modulus opens as a negative? It will be t minus h is equal to 1, and h is equal to 1 we know. So this implies t is equal to what? 2, right? So so if there are two tails and one heads, then this condition is possible, right? X can be equal to 0 and y can be equal to 1. So what is the probability of that? What is the probability of two tails coming up? Quite simple. So you have three tosses, right? You choose any two toss, 3c2, and uh, two times it has to. So and so since it is a fair coin, you can just write 1 by 2 raised to 3, right? So this will become what? 3 by 8. So this thing is equal to 3 by 8. Uh, Similarly, okay, just a second. Similarly, I will just erase this and rewrite for the next case. What is the what is when is this situation possible? H minus t is equal to 3 and h is equal to 1. So if this modulus opens up as positive, then h minus t will be equal to 3. And since h is equal to 1, this implies t is equal to minus 2. That is not possible, right? So this case is not possible. What if uh, what if what if this modulus opens up as negative? So t minus h is equal to 3 and h is equal to 1. This implies t is equal to 4. That is also not possible because if you're tossing the coin three times, it is not possible to get tails four times, right? So that is also not possible. So this is a not this case is just not feasible. So it's a zero probability thing. Uh, now now you can do use some brain here, right? Because now instead of calculating things again and again, you can think of this as, symmetry basically. So if x is equal to 2, which means that number of heads is equal to 2, that means that number of tails is equal to 1, right? Because if you're tossing the coin three times and two times it's heads, then the third time it has to be tail, right? And you have to again find the difference, this thing, uh, and you are given that the difference between the two is equal to 1. This case is actually similar to this case. Why? Because heads and tails are actually just symmetric, right? I mean, like this, since it is a fair coin and you are using this absolute value, everything is symmetric. So you can just copy this thing here, 3 by 8 and 0. Similarly, yeah, these two things will be basically symmetry. Because of symmetry, they are the same. That's all. Similarly, if x is equal to 3, right? Then that means the number of tails is equal to 0, right? And which is similar to this case when your number of heads is equal to 0. I mean, I'm using symmetry here, okay? Let me know if it's not clear, but you can just again write this 0, 1 by 8. That's all. I'll just erase this thing. So this is like the probabilities of all the possible events that can happen, right? Uh, what else do you need? Uh, what else do you need? So you basically need one more thing. I mean, whenever you're creating a table, it's better to, make this thing as well. Probability of y equal to y. So what is the probability that x is equal to 0? You can just add these two things, right? Because they are partitioning that x equal to 0 event. So this will be equal to 1 by 8. This will be equal to 3 by 8 plus 0, which is 3 by 8. This will be again 3 by 8, and this is again 1 by 8. Similarly, what is the probability of y equal to y? You just need to add this in this direction now. This will become 6 by 8, and this will become what? 2 by 8. And this, the sum of all these has to be equal to 1, which is what you get here. Now, coming to the question, you have to find probability of x equal to 1 given y is equal to 1. What is that? This will be equal to probability of x equal to 1 comma y equal to 1 divided by probability of y equal to 1, right? By using Bayes theorem. And what is this? Probability of x equal to 1, y equal to 1. It's this thing, right? It's 3 by 8. And what is the probability of y equal to 1? So you have to see probability of y equal to 1, which is 6 by 8, right? This is 6 by 8, and this will be equal to 1 by 2. That's all. So yeah, so this probability is equal to half. Let me know if it was not clear. I mean, was that clear? I'm not sure. Can you just write me which part? The table. I will explain this. I will explain this part, and you can similarly find out list. Let me know if I will explain this thing, how I calculate 3 by 8. If that is not clear, you ask me, but all the rest of the things are just obtained similarly. Okay. So you're given that what x is equal to 1 and y is equal to 1. Okay. Now what is y? Y is equal to mod of h minus t, right? And what is x? X is basically h. the number of heads. It is given to you that mod of h minus t y is equal to 1. This is equal to 1, and it is given x is equal to 1. That means h is equal to 1. Okay, this much is clear. Okay, so now this mod can open in two ways, right? So h minus t can either be just h minus t if the modulus opens up as positive equal to 1, or it can open up as negative like t minus h, which is equal to 1, right? In this case, in first case, if h is equal to 1 and h minus t is equal to 1, what will t be equal to? T will be equal to basically uh, 0, right? Because this is equal to 1, so 1 gets cancelled, t will be equal to 0. And in this case, t will be equal to 1 plus 1, which will be equal to 2. In these two cases, this thing is not possible, because if h is equal to 1, right, it means that t has to be equal to 2, because it cannot be that you toss a coin three times and you never get, you get once you get heads, and the rest of the time you get nothing. Understood? Did you understand? What did you say? It was not clear. Okay, okay. Okay, so this is done. Uh, let's solve another question. Third question, right? Uh, the question is, now you have x and y, two continuous random variables, okay, and it's given to you that their joint distribution is given by is given as follows: 6 times 1 minus x minus y when x is greater than equal to 0, y is greater than equal to 0, and x plus y is less than or equal to 1. Okay, and it is 0 otherwise. This is given, right? Okay. So this is the joint density function that is given to you. The question that is asked is, what is the expected value of y given that x is equal to 1 by 3, right? This is the question that is asked. Now, uh, first of all, if you want to find this thing, how do you calculate expectation, right? This thing is equal to what? Integral of y times f y given x of y given x equal to 1 by 3 dy, right? This is what your value is, right? And this will be equal to what? Integral y. This conditional density can be written in from Bayes theorem. This can be equal to what? X equal to 1 by 3 comma y divided by f. So this is joint density, and the denominator will be just the marginal x equal to 1 by 3 dy. This is what it is, okay? So for this, so the joint density is already given to you. You have to find out the marginal, okay? So what is the marginal density of x? So for that, you will have to, so fx of x, this is simply what? Fxy of x comma y dy, and you integrate it appropriately, right? So what will that be? So it is given to you that uh, the x and y, they are non-zero only in this, given in these conditions, right? So x has to be greater than or equal to 0, y has to be greater than equal to 0, and x plus y has to be less than equal to 1. So what is it? This is 6 times 1 minus x minus y, right? 6 times 1 minus x minus y dy. Now you have to choose the limit of y. So y is always greater than or equal to 0. So the limit has to start from 0 because that is the least value. And it is given to you that x plus y is less than or equal to 1. So y has to be less than equal to 1 minus x. And it was given to you that y is greater than or equal to 0, right? So the limit of y starts from 0 and it is always less than 1 minus x. So it has to go to 1 minus x. I am just putting the limits from the given condition, okay? This is the given condition. I have just calculated the limits of y using these conditions. You do this thing, what will this become? So this will be 6 times, so this will be y minus xy minus y square by 2, starting from 0 to 1 minus x, right? Uh, Now just you substitute this limit in this expression. It will become 6 times. So 1 minus x minus x times 1 minus x minus 1 minus x whole square by 2, right? This is what it will be, minus 0 of course. And from this 1 minus x gets common, so this will become what, 6 times 1 minus x whole square minus 1 minus x whole square by 2. This will become 6 times 1 minus x whole square by 2, 2 threes are, and this will become 3 times 1 minus x whole square. And when is this valid? X should be greater than equal to 0, right? You need to remember that x has to be greater than equal to 0. Only then this is possible. Okay, now this is the marginal, right? This is the marginal distribution, uh, right? Okay, so if this is the marginal, what is the this thing? Now using this thing, right? This formula, expected value of y given x is equal to 1 by 3. This is equal to integral y fxy, maybe I will write it down, fxy of 1 by 3 comma y divided by fx of 1 by 3 dy. Okay, so this is what integral y fxy, the joint distribution is given by this thing, 6 times 1 minus x minus y, right? So 6 times 1 minus x is 1 by 3 minus y divided by fx of 1 by 3. Fx is 3 into 1 minus x whole square. This is 3 into 1 minus x is 1 by 3 whole square dy, right? And what is the limit of y? Again, y is always greater than equal to 0, so it will start from 0 until where will it go? We just saw that y is less than equal to 1 minus x and x is equal to 1 by 3, right? So this will become 1 minus 1 by 3, which is equal to 2 by 3. So this will go till 2 by 3. And so what is this integral equal to? Just simplify the 3 2s are 6. 2 times 1 minus 1 by 3 is 2 by 3 minus y divided by 1 minus 1 by 3 is 2 by 3 whole square, right? So this will be 4 by 9 dy. Uh, just simplifying things, so this will become 2 2s are, and the limit is 0 to 2 by 3. Uh, what will this become? 0 to 2 by 3. This will become what? So 2 9 by 2 into 2 by 3 into y minus 9 by 2 times y square. This thing dy. This thing 3 3 is a 9, 2 2 gets cancelled. So this will become, now just integrating it. So 3 times y integration is 3y square by 2 minus 9 by 2 y cube by 3, and the limit is 0 to 2 by 3. So if you put, so this 3 3s are 9. So this is equal to what? 3 times 3 by 2 times y square. Substitute y to be 2 by 3. 2 by 3 whole square minus uh, 3 by 2 into y cube, which is 2 by 3 ka whole cube. Right? So this will become what? So this is square times its inverse, right? So this will become just 2 by 3 minus 2 by 3 whole square, right? Uh, right? So this will become what? 2 by 3 times 1 minus 2 by 3, which is 1 by 3, and 2 by 9. So the answer is 2 by 9. So this is just a lot of calculation, right? There's nothing significant in it, just a lot of simplification. Let me know if something was not clear, okay? But otherwise, it was just a lot of calculation that I did, just nothing else. Hmm. Okay, moving to the next question, right? So, next question is again a simple one, not very tough one. Uh, so this is what this was third question or second of the third question. So let's look at fourth question. So now the question is as follows, right? So there are two random variables x and y. They can take value of the form I comma j. Okay, I can be equal to what? 0, 1, 2, and j can be equal to 0, 1, 2. So x comma y can take the values of form. So x equal to I and y equal to j. These are the kind of values that these random variables can take, and it is also given to you that the possible values that I can assume is 0, 1, 2, and j can assume is 0, 1, 2 again. Okay. So and additionally, it is also given that probability of x equal to I and y equal to j, this thing is equal to what? C times I plus j. This is given to you, where c is some constant, c is some real valued constant, let's say. Okay. So the question that is asked is which of the following are correct? The first option is expected value of x is equal to expected value of y. B option is variance of x is equal to variance of y. C option is c is equal to 1 by 18. And D option is expected value of x is equal to 2 by 3. These are the questions that are asked to you. Okay. So actually first two option you can just straight away answer. Is expected value of x equal to expected value of y? Well, if you look at it, x and y are symmetric again, right? Because they are taking values in the same uh, codomain, right? Or at least the range of, sorry, I should, yeah, I mean, the range of these random variables, the values that they can assume is same. And more than that, the probability, a mass function is actually again symmetric. I mean, c times I plus j is equal to c times j plus I, right? So it doesn't matter. So what do I mean is probability of, let's say, x equal to j and y equal to I. This is also c times j plus I, right? Which is equal to probability of x equal to I comma y equal to j. So these are like symmetric random variables, right? I mean, if there is nothing special about x and there is nothing special about y, you can straight away say that because of symmetry, expected value of x will be equal to expected value of y. Also, the variance will also be the same, right? Because there's nothing I mean, special about them. They're just symmetrically, I mean, they're just like they're identical, is what I'm trying to say. That's all. Okay, so the question, so what about the other question, other options? C is equal to 1 by 8 and all those stuff. Okay, so again, whenever you have like discrete random variables at your exposition, you just create a table. Okay, so what are the possible values that x can take? Let me use the blue color. So x can take 0. I mean, it is given to us, right? 0, 1, or 2. X is equal to 0, x equal to 1, x equal to 2, y equal to 0, y equal to 1, y equal to 2. And it is c times I plus j. I plus j is here is 0, so c times 0 is 0. C times 1 plus 0 is c. C times 2 plus 0 is 2c. Okay. Similarly, this will be c. This will be 1 plus 1 2 times c, 2c. 2 plus 1 3c. Right. Uh, what else? X equal to 2 plus 0 is again 2c. This will be 1 plus 2 3c. This will be 2 plus 2 4c. And what is here, you can write probability of x equal to x. You just add it like this. So it will become 3c, and this will become 3c, 2c, 5c, and 6c. 7 plus 2 9c, right? And here you can write probability of y equal to y, which is equal to 3c, 3 to 5 plus 1 6c, 4 3 7 plus 2 9c, and this thing here should be sum of all of these. So what is that? 9 6 6 3 9, 9 plus 9 18, 18c, right? So yeah, this is 18c. Yeah, so we know that 18c has to be equal to 1 because it's the probability of all the events, right? I mean, probability of omega, so to say. This implies c equal to 1 by 18, right? So this option is also correct. This option, c is equal to 1 by 18, is also correct. That's all. Now last question was, what is expected value of x? This thing, we need to find expected value of x. So this will be equal to summation of x into probability of x equal to x, right? What is the value of x that it can take? 0, 1, or 2, right? So first will be 0 times probability of x equal to 0 plus 1 times probability of x equal to 1 plus 2 times probability of x equal to 2. This thing is 0. What is this thing? This is equal to 1 times probability of x equal to 1. That is 6c, right? 1 times 6c plus 2 times probability of x equal to 2. That is 9c, right? So this is 9c. So the sum of this will be 24c, right? 9 to the 18 plus 6c, 24c, which is equal to 24 into 24 by 18, right? So this is the expected value of x, and the option that is given is 2 by 3. So this is not correct. This is the wrong option, right? So I've just used the formula of expectation to find this thing. Let me know if it was not clear, okay? Yeah, if it is not clear, you let me know. Otherwise, I will just move on to the next question. Okay, moving on. Uh, yeah, so let us look at another question. This is fourth, right? Fifth question. So you are given that x comma y. This is a bivariate random variables. Okay, uh, and it is given to you that their correlation function is given by rho of x comma y. Okay, this is given to you. So there are some statements that is given to you, and you have to tell if these statements are true or false. Okay, so the first statement is Rho of x comma y equal to 0 implies that x and y are independent. This is the first statement. The second statement is x is independent of y implies that rho of x comma y is equal to 0. Okay. Third thing is uh, what is the third thing? Third statement is if x comma y are bivariate bivariate normal random variables, then x and y are independent if and only if rho of x comma y is equal to 0. And the fourth statement is rho of u comma v is equal to 0 where v is equal to u square and u is standard normal random variable. These are the first statements that are given to you, and you have to tell whether each of them is true or false or whatever. Okay, so maybe I'll just so I mean, if you have any question, you can ask. Otherwise, I will just take a sip of water. Okay, so no questions. So let's start with the fourth statement. So it's given that v is equal to u square. Okay, and u is normal 0 1. So let us see what is the covariance of u comma v. Covariance of u comma v will be expected value of uv minus expected value of u times expected value of v. So u times v is u cube, right? U cube minus, we know that expected value of u, since the mean is 0, this thing is actually equal to 0, right? So this will just become 0. And expected value of u cube, because the odd moments uh, of standard normal are always 0, this will be just 0. Okay, so this is the property of standard normal, that all the odd moments are equal to 0. So just using that, so u cube is an odd moment, so that is equal to 0. So this implies that rho of u comma v will also be equal to 0. But now here you can see, right? So this statement is correct. So this statement is correct. However, one thing to notice here is that, see, rho of u comma v, the correlation is equal to 0, but v is equal to u square, right? I mean, u and v are not independent here. And they are not so yeah, they are not, clearly they are not independent, because the value of v depends on the value of u. So I mean, so this actually tells us that the first statement is actually wrong, because here we have seen a here we see an example where the correlation is 0, but they are not independent, right? So correlation and covariance always capture the linear dependence. If they are linear, you get correlation to be 1, and it sort of captures linear correlation. It doesn't capture the non-linear correlation and stuff. So yeah, so this example tells us basically a counter example of uh, actually tells us a counter example of how two random variables can be uncorrelated but they are not independent. Okay. Now let us look at the second statement. If x is independent of y, does it imply that rho of xy is equal to 0? So x is independent of y, right? What is rho? So let us look at the covariance, right? Covariance of x comma y. This is equal to expected value of xy minus expected value of x times expected value of y. Okay. Now, since x and y are independent, expected value of xy will be equal to expected value of x times expected value of y because of independence, and minus this thing, x times expected value of y. Now these two things will cancel out, this will become 0. So this statement is correct that if x is independent of y, this implies that rho of x comma y is equal to 0. This statement is correct. What about the third statement? X, y are bivariate normal random variables, then x is independent of y only if. So basically the question is this statement, so the first statement in general is not true. The second statement is always true, okay? That if they are independent, then the correlation is 0. But the first statement is not always true. That if they are uncorrelated, then they are independent. The question is it true in the case of uh, bivariate normal distributions? So the answer to this is actually yes, okay? So I mean, x is independent of y is equivalent to saying that rho of x comma y is equal to 0. Okay, this side is always true. Okay, however, this side, sorry, okay, I write something. This is wrong. Uh, this side is always true that if they are independent, then they are uncorrelated. However, if they are uncorrelated, it need not be that they are always independent. Okay, not always true, but true for bivariate normal. Okay, so this is the catch that in case of bivariate normal distributions or in case of joint Gaussian distributions in general, uncorrelatedness implies independence. And how can we prove that? It's quite simple. You just look at the moment generating function. Okay, so let's say you are looking at the moment generating function of mxy of s comma t. For Gaussian distribution, jointly Gaussian distribution, this is equal to what? You should remember this mx of s times my of t, right? Times e raised to rho sigma x sigma y st, right? This is the relation between the moment generating function of the joint random variables and the individual moment generating functions. Now, if rho is equal to 0, this term will be equal to 0. So, e raised to 0, this thing will go to 0. E raised to 0 will become what? Just this will become 1, right? So, this will become mx of s times my of t, and this is mxy of s comma t. Now, whenever the joint moment generating function is equal to the uh, uh, product of individual moment generating function, this implies that x is independent of y, right? This is the property that I am using because the moment generating function itself are kind of decoupled, right? That means that x and y are actually independent. So, yeah, I mean, this is a simple proof to see it, how it is happening. Okay, let me know if it is not clear. Uh, Otherwise, I will move on to one more question. So this was what, sixth or fifth? Fifth question. We'll move to next question if it is clear. Which part? The whole question, the entire question, is it? Uh, okay, fine. So the okay, I mean, and I won't go in like the whole depth, but I will just explain it. Uh, from I will just give you the gist of it. So the question is basically the, the question is basically asking you that what is the relation between independence and uncorrelatedness? Is it true that x is whenever x is independent of y, the the correlation coefficient is equal to zero? That is the first statement, that if this is zero, then does that imply that x is independent of y? The second statement is, if they are independent, does that mean that they are uncorrelated? That is the second question. And the third question is, in case of a bivariate normal distribution, are both of them true? Okay. So there are two things: independence of random variables and uncorrelatedness. So it can be seen by simple, manipulation, that when x and y are independent, then rho of xy is always equal to zero. So this side of this side is always true. If this is true, then this is always true. Okay, irrespective of whatever random variable you are talking about. However, the opposite side, that rho xy is equal to 0, then x is independent of y. That is not always true. We saw that using this example. So if u is a normal, standard normal, and v is equal to u square, the rho of u comma v is equal to 0, but it's clear that v is equal to u square, and hence v and u are not independent. Okay. So this opposite side is not always true. However, it is true for bivariate normal distribution. And how do you see that? You just look at the moment generating function of the uh, s- joint joint moment generating function, right? It is mx times my times e raised to rho sigma x sigma y st, and rho is equal to 0 is given to us. We will assume this thing, and if that is 0, then e raised to 0 will be equal to 1, and hence mxy is equal to mx times my. This implies that x is independent of y, because if moment generating functions are decoupled, then it means that they are independent of each other. So the gist of this is that uncorrelatedness implies that the random variables are independent in case of bivariate normal distribution, or in general, whenever the random variables are jointly Gaussian, uh, the uncorrelatedness implies that they are independent, and it's the case only in case of Gaussian random variables. No other distribution follows this thing. Is that clear now? Okay, so let's look at the next question. The next question is, basically you have a square S. Okay, it has, so let's draw it on a Cartesian plane. It has four vertices. Uh, the first vertex is at 0 comma 1 minus 1 comma 0, 0 comma 1, and 0 comma minus 1. So this forms a square, right? Okay, and basically it is given to you that uh, it is raining on this square. Okay, and at any point x comma y, so uh, maybe what I will do is I will just, so yeah, so this is 1 0, yeah, right? So these are the vertices of the square, and a raindrop falls on the square at random. Okay, so it's like you can imagine a dartboard with this square, and you are throwing a dart at this square. Okay, and there are two random variables. So let's say your dart falls at a point x comma y. Okay, there are two random variables that are coming from it: x of x comma y, which is equal to x, and y of x comma y, which is equal to y. So it's like if you throw a dart on this square, the x coordinate of that uh, the x coordinate of that point is your random variable capital X, and the y coordinate of that point is your random variable capital Y. Okay, and what is given to you is the joint density of x comma y. So fxy of x comma y is given to you to be what? Is given to you to be half when x comma y belong to this square. It is 0 otherwise. So maybe I will repeat the question. The question is, there is a square, okay, and you are throwing something at it at random. Whatever point it hits, whatever, so let's say it's a dart board and you are throwing a dart, whatever the x coordinate of the dart is at the point that it follows, it's that the x coordinate is the random variable capital X and the y coordinate is the random variable capital Y. And it's given that they follow this since these two are random variables, they have a joint distribution function, and it is given by this expression that is here. Okay, so basically it is saying that x comma y, it has a uniform distribution. Okay, uniform distribution over S. This is given to you. Uh, what is the question? So there are four options that are given to you. The first option is expected value of x is less than expected value of y. Second option is variance of x is less than variance of y. Uh, C is x is not independent of y, and D option is x is independent of y. These are the four options that are given to you, and you have to find out the correct option. Which of these is the correct option? So again, I mean, just by common logic, right? You can again see that x and y are again symmetric, right? I mean, if I just rotate this Cartesian product by just 90-degree, right? Nothing will change. X will become y and y will become x, right? So since these are symmetric random variables, you can blindly tell that expected value of x will be equal to expected value of y and variance of x will be equal to variance of y. This will always be true because just because of the symmetric nature of the random variables, right? Because if you change, I mean, there's nothing special about x, right? It's a spatially it's symmetric, and if you just rotate this thing by 90-degree, y will become x and x will become y. So there's nothing special about x or y. They are interchangeable. So because of this thing, expected value and all the moments will basically be the same. And since that is the case, the first two options are straight away incorrect. Expected value of x is equal to expected value of y, it's not less than. Similarly, the variance of x is equal to variance of y, it's not less than variance of y. What about independence, right? So for independence, you need to check whether for independence you have to check if xy of x comma y is equal to fx of x times fy of y. Whenever you have to check independence, you have to look at this thing. Otherwise, you cannot, right? Okay, so let's look at it. So maybe I will draw the this that square again here. Okay, this is the square. Let's say. So this is x, this is y, right? So when x is between what -1 and 0, right? In this region, what is the distribution of x? Fx of x when x is between 0 and -1, what is it? This will be equal to what? Integral of fxy of x comma y dy, right? This is what, just marginalize out y, but what will be the limit of y? So so look at this figure, right? What is, so let's look at some x. What is the value of y that it can take? It can take value of y from here to here, right? What is this y? So this is a given x. What is the value of y here? So what is this line? This line is what? This is mx plus c, right? So y is equal to mx plus c. However, the slope is negative, so it's minus x, and the intercept is minus 1. So minus x minus 1. This is the line. This line is minus x minus that, right? So y is equal to minus x minus 1. And what is this line? This line is again y equal to mx plus c. The slope is equal to 1, so y equal to x. And what is the c? The c is plus 1 here, right? So x plus 1. So when x is between minus 1 and 0, y is going from minus x minus 1 to x plus 1, right? So this will become, so what is fxy? This is half, right? Just half. So half dy minus x minus 1 x plus 1. This will become 1 by 2 times just y with limit minus x minus 1 and x plus 1. This will become half times x plus 1 plus x plus 1, right? And this will become just x plus 1. This implies for fx of x is equal to x plus 1 when x is between minus 1 and 0. Okay. What about x when it's less than equal to 1 and greater than equal to 0? What about this, the second half? I mean, we saw this region. What about this region? So let's look at it. So again, I am making that square, right? So this is the square. Let's look at this region now. Okay. So let's say this is your x. What is the value of y that it can take? The value of y can go from here to here, right? This point to this point. Now what is this point? So this line, what is this line? This is y equal to mx plus c, right? So the slope is positive x, and what is the c? C is minus 1, right? The y-intercept is minus 1. So this is x minus 1. And what is this line? This is y equal to, again, this is negative slope, so minus x, and what is the c? C is plus 1 here. So for a given x, it can go from x minus 1 to 1 minus x, right? So again, fx of x is equal to integral fxy of x comma y dy going from x minus 1 to minus x plus 1. So this will be what? X minus 1 minus x plus 1 half dy. This is equal to half times y x minus 1 1 minus x. This is half times 1 minus x plus 1. So this is 2 minus 2x, which is 1 minus x, just this thing, right? So fx of x is equal to 1 minus x when x is between 1 and 0. So overall what you can write is fx of x is equal to, so it is equal to x plus 1 when x is between 0 and minus 1, and it is equal to 1 minus x when x is between 1 and 0. This is the distribution that you get, right? Now what you can do is you can use a trick basically. What is the trick? Since x and y are symmetric, right? Both of them will have the same density also. So fy of y you can write similarly. Just replace x by y. This will be y plus 1 when y is between 0 and minus 1 is equal to 1 minus y when y is between 1 and 0. This is by symmetry, right? Now see if f, so what you have to check is if fxy, the joint distribution is a product of the marginals or not. So let's look at one quadrant, right? Let's look at this quadrant. So in that quadrant, fxy is always equal to half, right? Is this equal to, what is the value of fx of x there? It's between minus 1 and 0. So x is between minus 1 and 0 in this region, right? So it will be x plus 1, right? And what is the value of fy of y? Y is positive there, right? So it's 1 minus Y. So 1 minus Y. So you can see that these two are not equal, right? So actually, so from here it's clear that the joint density is not the product of the marginals. That's why this implies that X is not independent of Y. And hence, amongst these options, this option is correct because X is actually not independent of Y, and this option is incorrect. Let me know if it was clear or not. I mean, I just did some uh, basic calculation, nothing else. If something was not clear, let me know. I will explain that part. Uh, all right. So if that was clear, then we will just see one more question and then we will stop. Okay. So this is the last question that we will solve today. After that, we will stop. So this was the sixth question. Let's look at the seventh question and we will stop. So here is the seventh question. So the seventh question is that x and y, x comma y, these are bivariate normal random variables. Okay. It is given to you that mu x is equal to 1, sigma x square is equal to 1, mu y is equal to 1, and sigma y square is equal to 9, and rho, the correlation coefficient, is equal to half. This is given to you. The question is, what is the distribution of y given? So it is the question is, what is the distribution of y given x when you are given x is equal to 2? Similarly, what is the distribution of x, like the conditional distribution of x given y when x and y is the random variable y is given to you to be 2? Okay, so this is like a joint normal distribution is given to you with all these parameters. The question is, uh, what is the value of the, like, what is the distribution of the conditional densities? So here you just need to remember one formula. Like, it's a simple, uh, so see, the thing is that if two random variables are jointly Gaussian or they are jointly normal, right? Then everything like the marginals, the conditionals, everything will be a normal distribution. It's a known fact. You can just remember it, okay? So so if y, so this is the formula. So y, so let's say y given x is, you denote it by, let's say, y, small y. This will be distributed again according to another normal distribution, which is equal to what? Which will have the mean mu y plus rho times sigma y by sigma x times x minus mu x. Okay, this will be the mean. And what will be the variance? The variance will be sigma y square times 1 minus rho square. This is the, like, the uh, identity that you need to remember. So let's say you are asked that what is the distribution of y given x is equal to 2, right? This thing will be distributed according to a normal distribution with normal. What is value of mu y? Mu y is given to you to be 1 plus rho is given to you to be half sigma y by sigma x. Sigma y is 3, sigma x is 1, so this will be 3 by 1. X is given to you to be 2 and mu x is again 1, right? I'm just substituting the values, nothing else. And what is the variance? Sigma y square. Sigma y square is given to you to be 9. 9 times 1 minus rho square. Rho is half, so rho square is 1 by 4. So this is normal. What? This will become 1 plus 3 by 2, right? So this is 5 by 2, comma. 9 1 3 by 4, 9 threes are 27 by 4, right? So this will be 27 by 4. So y given x is equal to 2 is a random variable which is distributed according to normal 5 by 2, 27 by 4. This is the mean, this is the variance. Simple. Similarly, if you have to find x given y, you can call this another random variable x. This is actually distributed according to another normal distribution with mean mu x plus rho times sigma x by sigma y minus uh, y minus mu y, and the variance will be sigma x square times 1 minus rho square, right? Now let's say you were asked x given y is equal to 2. This will be distributed according to normal. Mu x was 1 plus rho was half. Sigma x by sigma y will be just 1 by 3, right? 1 by 3. Y is given to you to be 2, 2 minus 1, right? And what is the variance? The variance is sigma x square is given to you to be 1, right? So that is 1 into 1 minus 1 by 4. And what will this be? Normal. So this will become what? 1 by 6 plus 1. So that is 7 by 6. And the variance is 1 minus 1 by, so this will be 3 by 4. So x given y is equal to 2 is distributed according to normal distribution with mean 7 by 6 and variance 3 by 4. So just a simple, this question might look very difficult, but if you remember this, this property of Gaussian random variables, that everything, the marginals and their conditionals, everything is actually normal. You can just simply use this to write this formula, and the rest of the things are very easy. So yeah, that was the last question that we were going to do today. Let me know if there are other questions. If there are no more questions, then we will stop here. Okay. Uh, okay. There are no questions. So I will stop presenting the screen and just leave this thing. Okay. If there are no more questions, then we will just end the session here. Thank you for joining. Have a nice day. Okay. Yeah, sure. Thank you. Have a nice day. See you. See you in the next session. Okay. Bye.